In this tutorial, we're going to learn about running SEAMM from the command line. In the first tutorial, you saw how to create a flowchart and run it through the graphical interface and get it into the dashboard. This time, we're going to take that and make it a little bit more friendly for using and run it from the dashboard to show the idea of getting command line arguments in. So what I need to do here is start SEAMM. It'll start up here in just a second. Maximize this window so you can see everything that I'm doing. And now we're going to go to Zenodo. This is a bit new. Zenodo is a very nice open source resource. It says open a flowchart from local files. Let's go to Zenodo. And Zenodo is a large depository, so we're going to filter what's out there by saying we want things to do, flowcharts that have to do with tutorial. At this point, there's just a couple of them. The first tutorial and the third tutorial. This one, fourth one, will appear in there in a second. I just want to bring your attention, there's this arrow. There are a couple versions of the first tutorial, and we could get either version. We want the most recent version, so we will click on that, and we will open that flowchart. So here is the flowchart from the first tutorial, and if you remember, it built a ethane thiol compound using smiles, and then ran DFTB on it. All very straightforward. But we can bring this flowchart back and we can run it again, but we can't change the molecule except by going in and editing the flowchart. So what we'd like to do is change that. So I'm just going to pull this over to the side. You'll see why in a second. Remove the arrow connecting the start with from smiles. The arrows give the flow of the logic in the flowchart. And put in a parameter step, and that's why I pulled from smiles. Otherwise, they would have been right on top of each other. Now I'm going to connect here. When you hover over a step, you get the dots. When you actually over one of the dots, it becomes larger, which means it's active. I can then drag over to the from smiles step. When the dot gets larger, I can let go of the button. And now we've connected the two steps, and we have a flow from start to parameters from smiles to DFTP plus. That's a bit ugly, but we can just automatically clean the layout. Now we've got a nice clean layout. Now what we need to do is go and set up a parameter so that we can tell it what molecule to run. So go into edit the parameters step. There's not much here to begin with. So click on the plus, that's the only thing we can do. And that allows us to add a variable. So we're going to give it a name, being very original. Just going to call it smiles. It shouldn't be a float, it should be a string, so let's change that. Single value is fine. We only want to run one molecule in this case. Optional, no, we need to have a molecule, so let's make it so it's not optional. Don't need to worry about the rest of the parameters. Maybe type some help in here. I'm just going to say it's the smiles for the molecule we want to run. And we click OK. That has given us a parameter that we can use elsewhere. So we save that. After we look at the summary, just check it's correct. And then we go into the from smiles step, which, if you remember, had a hardwired ethane thiol. Now what we want to do is replace that with the variable. So we select over that. And replace it with $smiles. That's the name of our variable. The dollar indicates it's a variable, so use the contents, not the actual name of the variable. Everything else is fine, so we're done. So can go into DFTB plus and change things, but it was perfectly fine the last time we ran, so it should be good, so I'm not going to do that. Now what we want to do is save the flowchart so that we can run it. What I'm going to do is save it in a directory as tutorial4.flow. I've already done this, so I'm going to overwrite the file. You shouldn't get that message. So now we've edited the flowchart, saved it as a new flowchart. Now we want to run it. To do that, we need to bring up a command window, a terminal window. And the first thing I'm going to do is notice that my conda environment is the base. I need to be in the SEAMM environment to run SEAMM, so I am going to activate the SEAMM environment. Now the SEAMM environment is activated, and I'm going to run this flowchart. So I'm going to type the path where I saved it. Your path may be different if you saved it somewhere else. And there's the flowchart that we just created. It's executable. Before I run, I'm just going to ask it for some help, and it'll tell me how to run it. So if I put --help, like all Unix programs, it'll give me some help. The first section gives me the gory detail of how to run this. It's got a lot of options, but we don't have to worry about most of them. And it tells us here that the positional arguments is smiles. That's what we just set up. So the name of the variable is smiles. It's not an option. It has to be there. And it's the smiles for the molecule. So that's fine. So now let's run that. I'm just going to run it. I'm going to put on ---- standalone, just so I don't put it in my data store and clutter things up. And now it needs an argument that's smiles. So there's the smiles for ethanol. CCO is the smiles for ethanol. So this will now run, and it will do what we've asked it to do. If we come back and look at it, the first section, it tells us the parameters. This is the section where it's describing the flowchart before it runs, and it tells us what the parameter is. It's string, and it gives us the description that we typed in. This is for other users. And then it tells us in the from smiles step, it's going to create the smiles from using the structure that's in the variable $smiles. Okay. If we go a little bit further down where it's running the flowchart, it echoes essentially the same information, but this time it tells us what's inside the variable where it came from, the command line. And when we go down to the from smiles step here, just a bit below, rather than telling us what the variable is, it tells us what the contents were. There's our CCO for ethanol, so it's going to build that structure. And then if we go down further here in the output, we will get the output from DFTB plus, where we see that it's running the optimization, gives us the total electronic energy and the formation energy, which is similar to the enthalpy of formation. It's the electronic one, so it's not exactly the thing, but it's reasonably close, so we get a feel for what the stability of the structure. Then down at the bottom of the file, as we've seen before, are all the citations, the references for what was used, the various tools, DFTB and so forth, that were used. Please feel free to run this again, run different molecules. With that, end this tutorial.